All right. We got a math buffet for you today. We got a bunch of skills we're going to be going over. We're on the cusp of Thanksgiving break, stovetop time, okay? The beard's coming in. It's game time. You ready? Let's go. Degree. We're going to be talking about monomial degrees first. Mono prefix meaning one, so it is a single term. Degree here is 0. We're going to give degrees and then talk about how we can come up with this. Degree here, oh, what's up? It's 5. You might think you know what you're talking about, but do you? Degree here, 7. Threw you off there, didn't I? Here's how you find the degree of a monomial. In simplest terms, the sum of variable exponents. Sum, meaning addition, of variable exponents. No variable exponents, degree of 0. Only had one variable exponent, it was 5. That's easy, that's nice. This one, 2, 4, 1. Don't sleep on that 1, degree of 7. Okay? Now, we're going to do one example of a polynomial. Think of the olden days, okay? When you met a family, all they did was introduce you to the eldest son who represented the family. That's how this works. Find how old each monomial is in this polynomial. Age meaning degree. Degree here is 7. Degree here, 6. Degree here, oh, what's up, 11? Joshua is the oldest son here, so the degree here is 11. Okay? Quick, easy degree. Bam, let's move on. Power properties. Woo! These were getting you guys, so I want you to focus with me through this whole thing. First up, we're just multiplying. We're just multiplying. So let's take this one at a time. Coefficients, nothing new. If they tell you to multiply, guess what you do? Multiply. -3 times 4, -12. Here's our first rule. With variables, when you multiply, you add like variable exponents. So if I have x to the 5th and x to the 3rd, when they multiply, I get x to the 8th. Plain and simple. Let's keep going. Y -2, y6 gives me y to the 4th. Very good. Z to the 1st. Don't sleep on those ones. And z to the -4th gives me z to the -3rd. Now we've done everything correct. And this would be wrong in a test because it brings us to another property. Negative exponents. Oh, no, no, no. You are never, ever allowed a negative exponent in your final answer. Remember what I said, a negative exponent. I don't want anybody looking here and going, oh, -12, not allowed. Shut it. That's fine. That's not. See, sour than sweet. Sour Patch Kids. It's me. This needs to move. With negative exponents, I call it travel papers. You got to go across the border, okay? If you're up top, you got to go to the bottom. If you're on the bottom, you got to go to the top. So these are all technically over 1 right now. So my final answer for this first problem would be -12, x to the 8th, y to the 4th, over z to the 3rd. Notice it's not negative anymore. You got travel papers. Here you go. Across the border, you're positive now. So, once you move, it is no longer negative. Final answer for the first one. All right. Fractions. Don't get scared. Don't get scared. Here we go. Said it before, I'll say it again. Coefficients, we're not teaching you anything new. Reduce. Reduce. 18 and 15. 3 goes into them both. 6 over 5. Okay? Now, there's 2 ways to think about this. You can do the subtraction top to bottom because we're dividing. Remember, if we multiply, we add like variables. So if we divide, we subtract. But a faster way that I think about it is, if they're both positive, let them fight. Just duke it out, ninjas. 8 versus 6, who wins? The 8 with how many left? 2 in the top one. Uh-oh, we got negatives. Can't fight yet. They're not positive that they want to fight. Get it? They're not positive that they want keep up. Needs to travel. So this 1's going down below. It's now +1 with the 3, making it y to the 4th. Didn't even have to battle there. 2 on 2. Out. They cancel each other out. That is your final answer for the second one. Doing all right? Moving right along. Ooh, power to power. Power to power. This is where we got to make sure we do it correctly. Coefficients. I am not, third time I've said it, not teaching you anything new. If they tell you to square 3, guess what you do? You square 3. But if it's x to the 5th squared, that's technically x to the 5th times x to the 5th. How many is that? 10. So you'll notice what we can do when it's power to power, you are multiplying exponents, which makes y to the 8th. Quick rundown of our power properties. We're killing it. Good job. Thanks. I know. Here we go. Combining like terms. Okay, couple things, guys. 1, when adding or subtracting, your variable exponents will not change. Again, I'm going to say it. When adding or subtracting, your variable exponents will not change. 2, you can only combine through addition and subtraction if terms have the same variables and same exponents. Again, you can only combine through addition and subtraction if terms have same variables and same exponents. Keep that in mind. Distribution. We get a 4a squared minus 8ab plus 12. Distribution. Everybody's fine. Plain and simple. Distributing a negative 2. Don't lose your negative. We get a negative 10ab plus 4a squared plus 6. All right. Let's look for our like terms. That first term I have up here has an a squared. Anything else with an a squared? Hello, right there. Which means I'm going to come up with 8a squared. You guys see that okay? New marker. I have an AB. I have negative 8AB and a negative 10AB, giving me negative 18AB. Last me numbers, get it, plus 18. Done. Now, I've seen a couple people do this. What did I ask us to do? Just combine like terms. Some of you get here and you're like, ooh, I want to pull out a GCF. I didn't say factor. Stop it. Next problem. Last problem. Woo! Go dancing. I got to make sure that this 2x gets distributed to everything and the negative y to everything. I'm going to have 6 products before I combine like terms. Did you see that? 6. Man, I got skills. Here we go. 2x cubed minus, now remember your skills from right here. 2x times a negative 3xy gives me a negative 6x squared y. Remember the x's will combine and we're going to add their exponents. 2x times y squared gives me a positive 2x y squared. They don't impact each other, but you can multiply them. All right, almost done. Distribute the negative y, we get a negative y, x squared y. Notice we'll always put the variables in alphabetical order. Even though the y was coming up first, when I multiply y by x squared y. All right, negative y times negative 3xy. Positive 3xy squared. Can you guys still see that? Yes, you can. Lastly, negative y times y squared, negative y cubed. Oh, let's get some like terms. There's only one x cubed. It stands alone. X squared y has to have an x squared and a y. Nope. Yup. Negative 6x squared y minus 1x squared y gives me a negative 7x squared y. Ooh, xy squared. So it has a single x and then y squared. Hello. 2xy squared, 3xy squared, 5xy squared. And lastly, the only thing I haven't used, stands alone, negative y cubed. And that is my final answer for multiplication. Whew! I'm tired. Are you? Hope this helps. Little rundown of the smorgasbord before Thanksgiving break. Enjoy your stovetop.